You know that feeling when you build a program that does something amazing, but then it forgets everything the moment you close it? It's a super common problem, and today we're going to solve it. We're going to dive into how to give your program a permanent memory, all thanks to the simple but incredibly powerful concept of files.
Right now, your program probably has a bad case of amnesia. See, while it's running, it keeps all its important info, like variables, user input, maybe some high scores, in what's called volatile memory. And trust me, volatile is the perfect word for it, because as soon as that program closes, poof, it's all gone, vanished into thin air.
And this isn't just some techie detail. It's a total nightmare for anyone using your app. I mean, imagine finally crushing that tough level, only for your high score to disappear. Or what about carefully customizing an application's settings, just to have them reset every single time? Yeah, without a memory, every single session starts from a frustrating blank slate.
So what's the fix? Well, it's actually beautifully simple. Files. The best way to think of a file is like an external brain for your program. It's a place on your computer's disk where your program can write down all the important stuff before it shuts down, and then, you guessed it, read it all back the next time it starts up. This whole process is called file input/output, or file I/O, and it is an absolutely fundamental skill for any developer.
Okay, so how do we actually use this external brain? It's not that complicated, really. Interacting with any file follows this really clear and logical life cycle. Once you get these 3 essential steps down, you'll be all set. Let's break it down.
First, you open the file. Think of this like picking up a notebook and turning to the exact page you need. You're establishing a direct connection. Second, you either read or write. This is the main event, right? You're either getting information that's already there or putting something new down. And third, and this part is absolutely critical, you close the file. This step saves all your changes and releases that connection, which prevents all sorts of nasty issues like data corruption.
Now, to pull off those 3 steps, we need to give our program some very specific instructions. We can't just tell it, hey, open the file. We've got to tell it how we want to open it. And we do this using file modes to set permissions and methods to actually take action. This slide breaks it down perfectly. The mode you choose is like giving your program a specific permission slip. If you use R for read, it's strictly look but don't touch. But W for write, that one's powerful and a little dangerous. It's like erasing the entire page to start completely fresh, so you have to be 100% sure you want to overwrite everything. For a safer option, there's A for append, which lets you just add new info to the very end. Getting this choice right is step 1 to protecting your data.
All right, so you've opened a file in read mode. How do you actually get the data out? Well, you've got a couple of options. The read method is like taking one giant gulp. It just sucks the entire file's content into one single string. This is awesome for small config files. But if you tried that with a huge data file, you'd probably crash your program. For that, you use readline or readlines. These are more like taking small sips, processing the file one line at a time, which is incredibly memory efficient.
Now, when it comes to writing, the action itself is simple. You just use the write method. But the outcome of that action is completely controlled by that permission slip we just talked about. If you chose W mode, you're overwriting. The old text is gone, completely replaced. But if you chose A mode, you're appending, which keeps all the original content and just adds your new text right at the very end. That little distinction is the difference between updating a log file and accidentally wiping it out completely.
We mentioned earlier how important it is to close a file. Honestly, forgetting to do that is one of the most common mistakes people make, and it can cause all kinds of headaches. But luckily for us, there's a modern, really elegant solution that makes it almost impossible to get this wrong.
The solution is this beautiful piece of code called the with statement. Just think of it as an automatic safety net. When you open a file this way, the program guarantees, and I mean guarantees, that it will be closed properly when you're done, even if your code hits some kind of unexpected error. It handles all the cleanup for you, making your code so much safer and more reliable. This simple structure is the professional standard for a reason. Using the with open pattern is pretty much the golden rule of file handling. It's clean, it's safe, and it prevents all those nasty problems like resource leaks and corrupted data. Seriously, if you take just one technical tip away from this today, make it this one. Okay, so we've got the fundamentals down. Now let's see what this actually looks like in the real world. Because this isn't just theory, right? These simple concepts,
Opening, reading, writing, and especially using that with statement, they unlock some incredibly powerful applications.
Imagine you're a data detective, and you're staring at a file with millions of records, way too big to ever load into memory all at once. By opening it and using a method like readline inside a loop, your program can sift through that mountain of data one piece at a time, finding patterns and pulling out insights without ever breaking a sweat. It's how you analyze the unanalyzable.
Or, how about this? Put on the hat of a security analyst. Every single web server out there generates these massive log files. By writing a script to read these files, you can build an automated watchdog that hunts for error patterns, tracks user activity, and even flags suspicious behavior in real time. You're not just reading a file anymore, you're building an active defense system.
So let's do a quick recap of the essentials. First, remember, programs are forgetful, and files are their memory. Second, always follow that open, interact, close lifecycle. Third, choose your mode, R for read, W for write, or A for append, and choose it deliberately. And most importantly, make the with statement your absolute best friend. It is the key to writing solid, error-free code.
By mastering these fundamentals, you've really unlocked a new level of power for your applications. They don't have to start from scratch anymore. They can learn, they can save, they can persist. So the real question is, now that your program has a memory, what will you teach it to remember? Thanks for tuning in.